Hi there. These are two questions that are applications of the Reminder theorem that look the same but might have different solutions. So let's look at the difference between them. The question says find A and B if the polynomial given here, a fourth degree polynomial, is divisible by that quadratic or by that quadratic. So two questions. Please pause the movie and look what's the difference between those two quadratics. And if you thought long enough, you'll see that the first one has no real roots and the second one has two real roots that are distinct. We can apply the method that we are going to use in question A. We can apply it for question B as well. But using skillfully the factor theorem means that in question B we can have a faster solution. So let's look at question A. Because there are no real roots, I'm going to do the long division. So pause the movie and try yourself. X to the power of 4 plus 2x cubed plus ax plus b divided by x squared minus x plus 1. So x to the power of 4 divided by x squared is x squared. When I multiply x squared by x to the power of square minus x plus 1, I get x to the power of 4 minus x cubed plus x squared. Subtract 2x cubed minus x cubed give me 3x cubed minus x squared plus ax plus b plus 3, that's 3x cubed plus 3x, so minus 3x cubed plus 3x squared. Let's use the same method. So when I multiply, I get 3x cubed minus 3x squared plus 3x. Subtract again, so I get 2x squared plus a minus 3x plus b. And finally plus 2, so 2x squared minus 2x plus 2. And when I subtract, I get a minus 1x plus b minus 2. I can't divide more because the degree here it's 1 and x doesn't go into x squared, so I stop here. But the question says that p of x is divisible by x squared minus x minus 1, so I should expect that everything cancels down. So here I should have gotten 0 and 0 to be divisible. Therefore, a needs to be 1 and b needs to be, that's b minus 2, so b needs to be 2. And that's my answer. Now, let's look at question B. In question B, I could use exactly the same method, so you can try yourself, but I have a simpler method in question B if I use the factor theorem. So in question B, I want p of x to be divisible by that polynomial, and I can write this as x minus 1 brackets x minus 2. So factor theorem tells me that p of x is divisible by, let's call q of x, if p of 1 is 0 and p of 2 is 0. P of 1 is 1 plus 2 plus a plus b. P of 2 is 2 to the power of 4, 16 plus 16 plus 2a plus b. Therefore, a plus b needs to be negative 3 and 2a plus b needs to be negative 32. Subtracting them, I get a equals negative 29. And therefore, b equals minus a, so 29 minus 3, 26. Now you can pause the movie and try question B using the first method as well to see that it is longer. On the next page, I solve question B using the method in question A. However, I would recommend to use extensively the factor theorem and the reminder theorem when possible, because it can make your calculations much simpler. Here is question B, solved using the method to use in question A, so using long division. Also, after you finish with the long division, read the question again to see why did you do the long division. So in this case, we did it because we wanted the remainder to be 0.